All right, welcome back to the explainer. Now, we've all heard that Python comes with batteries included. But today, we're going way past the standard toolkit. We're cracking open the professional toolbox, the modules that are designed to solve those tough, specialized problems you run into on real-world projects. So, you think you know your way around Python's standard library? You've got your lists and your dictionaries down, no problem. But there's a whole other layer of incredibly powerful, high-performance tools that a lot of people they just don't know about. And these are the tools that can really separate the pros from the hobbyists. And that's really the heart of it, isn't it? True mastery of a language isn't just about syntax. It's about knowing exactly which tool to grab when you're faced with a specific problem. And that's our mission today, to uncover those specific built-in tools that solve some really common but tricky programming challenges. Okay, so here's our tour guide for today. We're going to start by taming messy data with better formatting. Then we'll learn how to speak the language of systems with binary data. After that, we'll make our apps more responsive using concurrency, explore some specialized power tools for data, and finally, we'll make sure our math is perfectly precise. First stop, you know the situation. You pull a massive, deeply nested chunk of data from an API, you go to print it out to see what you're dealing with, and you just get a complete and utter mess, a giant wall of text. And this right here just says it all. On the left, that's what a standard print gives you. It's basically unreadable. On the right, that is the exact same object, but after running it through the pprint module. All of a sudden, it's clean, it's indented, and you can actually understand the structure. This little lifesaver is Print, the pretty printer. Seriously, it should be your go-to for debugging. It gives you all this sophisticated control to automatically add line breaks and indentation, making even the most complex data structures totally human-readable. Okay, but what if you need to let a non-programmer, say an end user, customize an email template? You don't want them messing with F strings and accidentally crashing your app. That is exactly where string.Template comes in. It uses these super simple $ placeholders and, crucially, has a safe substitute method. That means if some data is missing, it doesn't throw an error. It's safe, simple, and perfect. All right, let's shift gears and move from the human world to the machine world. A lot of the time, our programs have to deal with file headers, network packets, or low-level hardware. And that world, well, it speaks in raw, binary data. So, how do we speak this language? We use the struct module. You can think of it as Python's universal translator for binary. It takes your nice Python values like integers and packs them into a compact binary format that other systems understand. And of course, it can unpack that binary data right back into Python objects.
But how does it know how to translate? It uses these little format codes, which are basically a blueprint for the data. For example, if you were reading a zip file header, you might use a code like IIIHH. That tells struct, okay, I'm expecting little endian byte order, followed by 3 4-byte integers and 2 2-byte integers. It's an incredibly precise way to map binary data directly to your Python types.
Our next professional challenge is a really big one, the frozen application. You know, you click a button to download a big file or run a heavy calculation, and the whole user interface just locks up solid. It's an awful user experience. I mean, we've all been there, right? Staring at that spinning wheel of death, just wondering if the program has completely crashed. The problem, almost always, is a single-threaded app that's totally blocked, waiting for some slow operation to finish. The classic solution here is threading. You take that slow blocking task and you give it to Python's threading module to run in the background on a separate thread. This frees up your main program so it can stay completely responsive, handling clicks, and keeping the UI feeling alive. No more freezing. And here is a crucial pro tip. It's so tempting to have threads share data directly, but trust me, that way leads to madness and bugs that are impossible to track down. The best practice, the right way, is to use the queue module. It creates a safe, orderly way for threads to pass messages and tasks to each other. It's just cleaner, safer, and way more reliable. We all know and love the Python list. It's our flexible, powerful, do-anything data structure. But for some jobs, it's not actually the most efficient tool. Sometimes you need a specialist for better performance or to be smarter with memory. And picking the right tool here is key. So while a list is great for general use, look at these alternatives. If you have a huge sequence of numbers that are all the same type, array.array is way more memory efficient. And if you're constantly adding and removing items from both ends of a sequence, like in a queue, collections.dequeue is dramatically faster than a list could ever be. For our final stop, let's talk about something really important: money. When you're doing financial calculations, close enough is just not good enough. And you might be shocked to learn that Python's standard numbers, the floats, can sometimes be close enough in ways you really don't want. Just look at this. We're doing a simple 5% tax on a 70-cent item. With standard floats, the answer rounds to 73 cents. But if you use Python's decimal module, you get the correct answer, 74 cents. Now, a 1-cent difference might not sound like a big deal, but when you scale that up over millions of transactions, it's an absolute disaster. So why does this even happen? It's because of this. This is what your computer is actually working with when you try to calculate $1 modulo 10 cents. The fact is, most decimal fractions can't be represented perfectly in binary. It's not a Python bug, it's just a fundamental limitation of how binary floating point math works. So when should you reach for the decimal module? The rule is simple. Use it anytime you need exact decimal representation. This is absolutely critical for financial applications, for any situation where you need total control over rounding, or anytime the computer's answer must match a calculation that would be done by hand. So, the big takeaway here is that Python's batteries included philosophy runs really deep. For almost any specialized professional-grade problem you're going to face, there is a very high chance that Python already has a robust, well-tested solution waiting for you right there in the standard library. So I'll leave you with this question. The next time you're about to write a complex binary parser from scratch, or you see your user interface start to freeze up, think back to this tour. Which of these professional tools will you pull out of the toolbox to solve that problem more elegantly? Hey, if you found this deep dive into Python's toolbox useful, please take a second to hit that like button and make sure you subscribe to the channel so you don't miss our next explainer. And remember to keep that curiosity going. For more in-depth tutorials on Python and a whole lot more, be sure to check out our friends over at plus2net.com. Thanks so much for watching, and we'll see you in the next one.